Welcome to Equinox, where Rob and I are striking the balance between the light and the dark. This is episode 64. I love that number. My name is Joseph Darnell, and I'm joined by my good friend, Dr. Robert What just happened?
I don't know.
Tongue-tied. My good friend, Dr. Robert Carter. Hello, Rob.
Hey, Joe.
How you doing?
I'm doing fine.
We missed 1 week, and I can't remember your name.
Well, that's okay. I was on vacation, so I didn't remember anything.
I don't feel the same. I noticed we're recording in the studio again, and you've got a richer tan. Congratulations.
I have a nice tan. This is from paddle boarding with dolphins, from snorkeling in the Gulf in southern Florida. It was really tough. Saw manatee.
Really tough.
Yeah.
I'm so sorry for you. How far do you have to go down into the water to not get a tan?
Excellent, cool question. Depends on the water. UV is absorbed pretty quickly. Infrared's absorb even more quickly. It's very hard to get warm when you're underwater. If you're right near the surface, you can feel like the sun warming you, but if you go down a little bit, all the infrared gets absorbed.
So is this sort of like the atmosphere, where the atmosphere begins and ends? We can't really say the satellites are in the atmosphere like we talked about the other day. And we were saying like, the billionaires are out in space. And so,
here in Georgia,
really.
when we get like 1,000,000,000% humidity, I think it's fair to say that you can't tell when the ocean ends and when the ocean starts.
Right, we're still standing in the ocean right here, right now. That's believable, actually.
Yes, but the ocean has a more defined boundary because of the surface tension of water.
Does that mean that we're, not amphibious, but we can both breathe water and air?
You can breathe water if it's got 21% oxygen.
Fascinating.
That's the hexafluoride something or others that they developed. You ever see the movie The Abyss?
No.
Oh, great movie.
Okay.
And it would have been a greater movie if they left out the aliens.
Oh.
It would have been this Russian-American, spine-tingling, nuclear, underwater, we're going to blow up the world sort of thing, but there was aliens. It was like, what? But in one part, they took a little mouse, and they're describing this substance, which is a thick molecule that absorbs oxygen. And they put the mouse and they weighed it down in this liquid. And he freaked out, and he stopped, and he started breathing underwater. And you can do this with people.
Wow.
But
nobody talks about it, for one.
Well, because it's not practical.
Yeah.
It's hard to get it out of your lungs after you've been breathing it.
Ooh.
And the amount of effort that goes into sucking in this thick liquid and breathing it out again, it's extremely difficult. It's just simply not.
It feels about as painful as probably trying to use your eyes underwater. My eyes can't handle it. Just trying to see, pool of water or in the ocean water, it hurts my eyes too much. I can't handle it.
Funny thing about me being slightly farsighted, the water is a magnifier. So a lot of people have problems judging distance underwater. Yeah. But the ocean water wearing a mask is almost exactly like wearing my eyeglasses.
Sweet.
So it's perfect. So one time we're in the Key West Harbor Naval Yard, and they're going to rip out this seawall, which is made of corrugated metal. And they're like, the environmentalists like, no, there's corals growing on the metal. You can't take out the wall. And so the University of Miami says, oh, we'll take all the corals. So we just spent 2 days driving from Miami all the way down to Key West. It was miserable and cold. The water was about 60 degrees. It was 60 degrees outside, and it was cloudy. And we're inshore, not out on the reef. We're in this cloudy, boat basin. And the dive master from University of Miami was there, and he was doing most of the chiseling. And every time, he took this 1.5 2 foot diameter flat coral and hits it with the chisel, and it just falls right off the wall. And it starts falling down. I just reach out and grab it, put it in the bucket. At the end of the day, he's like, how'd you do that? It's like, how'd I do what? It's like, how'd you catch all those things? It's like, oh, it's because the water is a perfect magnification. There's no difference. It's normal looking. I just reach out because it's a proper distance.
Fantastic. It's like you were made for this job.
I was made to be a marine biologist. I guess I like that. That's cool.
So we're going to talk about bees after the show.
Yes.
And we haven't had a ton of time to really review what we wanted to do for this episode. But we had in mind to talk about climate change, and seeing as how the climate's always changing, I think that this is a good time to discuss it.
Okay, let's go.
What do you know about the climate changing?
I know it's a contentious issue.
Yeah.
I know that people get mad. I know that everyone's got an opinion. And I know that very few people, I'll say, I don't respect the opinions of most people on this issue. Regular people and scientists alike, especially politicians.
We've only talked a little bit about it indirectly as it concerned probably environmentalism in an earlier episode. And surprisingly, it's been in the queue and incubating for a long time. I know this is one of those things that scientific culture just brings up all the time.
All the time.
And not because...
Excuse for everything. It's sickening when, because of climate change. Like, no, man, it's not because of climate change, but they say it anyway.
Yeah, and we haven't avoided it. It's just not been one of those things that were grabbing us for the week. So here we are. It finally caught us.
Let me ask you a question. Does the Bible say the environment doesn't change?
No.
Well, it does say seed time and harvest and summer and winter shall never cease. That's what God promised Noah after the flood, right?
Sounds more like a promise that things are always going to be changing.
Oh, actually, you're right. There will always be seasons. Oh, no. But looking at Earth's history, looking at the fossil record really does look like a snapshot of a warm, wet environment.
Oh, that's a very good point. So it's not like you have fossils that seem to indicate that they were made in cold environments, icy environments, or
hardly any. And there's dinosaurs on Antarctica.
Or something akin to, it sounds like an oxymoron, but can you make a fossil in a dry environment?
You could.
Yeah.
But where are the fossilized deserts? We have fossilized marine environments and swampy environments. That's predominantly what the fossil record is. And when you look at all the coal in the fossil record, if that was all trees, there's about 10 times more trees on the Earth than exist now that used to exist.
Wow.
Higher levels of carbon dioxide and warmer environment.
But Rob, why are you bringing up fossils and, their conditions? We were talking about the weather a moment ago.
Because if you bury a tremendous amount of carbon, you affect the weather. You affect how much plant life is on the world. You affect the amount of carbon dioxide, the amount of heat trapping by the atmosphere.
Oh, so you're saying, given the conditions that created the fossils, you're dramatically changing the climate.
Yes. I think the climate is radically different today than it was in the past. That's from a biblical position.
So the thing about that is that the Bible itself doesn't really go into weather reporting, tell us what it was the day that Moses, fled from Egypt and came back.
Actually, there's some really interesting things in the Bible about weather and that surprise you. Like the book of Job has more references to snow and ice than all the rest of the Bible put together.
And he was fairly early in human history too.
Depending on who you talk to, some scholar, oh no, Job is a very, very late, blah, 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 blah. But no, Job really does look like a very ancient book. But also when, during the Battle of Five Armies, that's from
that was
right.
That was other Bible.
Baggins.
That's from the other Earth.
When the five kings invaded the Canaan area and stole Lot and Lot's family, and Abraham goes and chases them. Well, part of that account, they're down at the Dead Sea, and people are falling into these asphalt pits. Well, we can tell the level of the Dead Sea at that point.
Oh. Cool.
And then when they're dividing up the land after the invasion of Canaan, they're picking reference points along the Dead Sea. We can tell the sea level at that point. We can tell that the sea level changed between Abraham's time and Moses' time.
So
that's really cool.
That is fascinating. And one thing I don't understand about climate changing and the levels changing is that anytime there's an archaeological dig, they're always going down, and they go down and they go into the past level where a previous civilization, village, or something existed.
Yeah.
Like people saying that there's whole pyramids under sand.
Yes, there are.
That means that the landmass has been rising.
Or if you have a pyramid out in the Egyptian desert, you get enough wind blowing over 1,000 years, and you're going to bury something as large as a pyramid.
Oh, I thought you were about to say that over 1,000 years, a pyramid would sink.
Well, there are cities that have sunk. There's a city off the north coast of Egypt that's underwater. There are ruins all around the world of structures underwater. Because
the impression I've gathered is just this idea that over time the land mass is accumulating over top of all of civilization, but that doesn't really make any sense. Like, what is the cause and effect that always buries the past? Or is that way off base? No. Not every civilization gets buried because...
This is true, not every civilization, but what typically happens is that the prime real estate, people keep living there.
So in New York City, for example, the level shouldn't change over the next 1,000 years if it continued to be inhabited.
But buildings will fall down, and they'll build another building on top of that building, and then the giant trash heap that is called Staten Island. I remember driving as a kid past Staten Island. It just smelled, because it was a giant New York City dump on the northern end of Staten Island.
It'd be okay if that got buried.
Well, yeah, but the dump in the town I grew up in, about 80 miles east of there, they turned it into a park. That's where we played Little League games. But it was the dump. I mean, as a little kid, we went there and threw all our trash in a big hole. And eventually it filled up. We, grassed it over, and it was a nice little park there.
Nice.
So ancient cities, Troy, you name it, Jerusalem, they tend to get destroyed, and then another culture will build something on top of it, and they get destroyed, and someone builds something on top of that, and you have all these different occupation levels. And plus, in the ancient world, they didn't have dumps; they just threw stuff out. Now, it was always a challenge dealing with human refuse and bones and animal skins and stuff like that, and they had ways to take care of that. But pots and beads and garments, they just get trampled underfoot. And over time, it would build up another level, another occupation level. That's really interesting.
Yeah.
But
that always mystified me a little bit when people would say, hey, we're going to tour Jerusalem and see where the disciples walked, and Jesus was right here one day. But then other days of the week, you listen to some archaeological find, and they're saying, yes, the Jerusalem that Jesus walked on is 20 feet down here, and it's 20 feet below the current level.
Yes, but especially around the Temple Mount, because the Romans knocked everything down outside the temple, and so all the environment around the temple got buried under a lot of rubble.
Okay.
And so when we're digging through that, it's actually Roman fill material.
Okay.
And then you add centuries of grass growing, and grass adds carbon, and then you have dirt starting to build up, and you get increases in thickness of detritus over time.
And is it safe to say that as the thicknesses change, it's not evenly dispersed even in a 50-mile radius? Yeah. So there's areas that are getting thicker and others that are receding even in a small area.
Yeah, when the ABR, the something for biblical research, the Associates for Biblical Research, when they excavated a particular place that they thought was the biblical Ai, which is the first battle after Jericho, as Israelites are coming up the hill toward the Jerusalem area, they lost this battle of Ai. And then they had to go back again, and then they won the battle. And traditionally, people said, this is the city of Ai. And the ABR is like, no, that doesn't match the biblical description. We think it's over here. So they started digging, and within just 6 inches, they hit Bronze Age material. So no one had ever occupied that site again. I think there was a Byzantine church built on top of it or something like that. But it was literally like right there beneath the surface, not very far down, was this ancient city that they were looking for, or something that sure looked like it. So it all depends on where you are. Like the first guy who excavated Troy, first real modern archaeological excavation, and he destroyed a lot of things. But basically he said, okay, this is the site of ancient Troy. I'm going to dig a giant wedge. And he dug through all these other civilizations and destroyed all that material and said, ha, I found ancient Troy. Woo. So we do it a little more carefully now. But that particular site, unlike Ai, which is a little backwater on the back slope of a hill, Troy is facing the Dardanelles or the Bosphorus or the waterway that connects the Black Sea to the Mediterranean, and is a very, very important, just like Constantinople, a very important place to regulate trade in that waterway. So people built on it many, many times.
All right, well, back to fossils and the weather of fossils.
Yeah.
They have a timestamp on them in terms of the weather. Lucy, kind of an idea that they were in moist environments.
Yep. And today is not like that.
Yeah, I can't imagine what would possibly have given those conditions.
Well, from my perspective, the pre-flood world was warm and wet, and it got buried during the flood, and the post-flood world is very different. And even in the post-flood world, we've had lots of changes. There was a giant famine during Abraham's time. There's a giant famine during Joseph's time. There are various famines in other times of biblical history. We know that sea level has changed a lot in some areas because of the Ice Age. The Ice Age, which was triggered by Noah's flood, which lasted for several centuries after the flood. When you build up a mile of ice on top of land, it pushes the land down into the earth because hot rocks it's not melted underneath the earth, but hot rocks are more bendable. And so you put up a mile of ice and the land goes down. And then when you remove that ice, the land rebounds. And satellite measurements are showing us that there's still land, like
still
Wisconsin
rippling?
area. It's still rising after we took away all that massive ice. Now, it would have risen faster in the past, but now it's still moving today.
Yeah.
And in England, the ice wasn't on southern England. It was only on northern England. So it tilted England up. Southern England went up in the air because the north end of England was being pressed down.
Wow.
And so today, Scotland is rising and maybe Cornwall's going down. And we can see those things. That also affected sea level. You go to the Great Barrier Reef, You go down a submarine about 100 meters, and there's an old beach.
Underwater?
100 meters down. There's a wave-notched platform.
So what do you mean by that? So I would imagine a beach is made of sand and it would have eroded like the day it got covered over.
The limestone that the Great Barrier Reef is growing on top of has a wave notch 300 feet down below the modern surface.
Oh.
That's where the water level was during the Ice Age.
Wow.
The Great Barrier Reef did not exist during the Ice Age.
Wow.
It has only grown since the end of the Ice Age. Now, the evolutionists would say, the Ice Age ended about 10,000 years ago. And I would say, okay, the Ice Age ended about 4,000 years ago. That's about the same number. There's not much of a difference there.
It's true.
And so if they can say the entire Great Barrier Reef grew in 10,000 years, I'm going to say the entire Great Barrier Reef grew in 4,000 years, and we're talking about the same thing. So we know sea level changes. We know land can subside. We also, there's a problem when you're building on a delta like New Orleans. You build a city on top of mud and you squeeze all the water out of the mud and your city sinks.
Yeah.
And that's happened more times in history than most people realize. You get subsidence, sea level changes, big rushing rivers versus a trickling. There's a particular, I wish I knew I wish I remember where this was. There's an ancient city in a desert in India. It's derelict. There's no one lives there now. It's just desert ruins.
Got cut off from like a
and
inhabitable
boat docks in the city in the middle of the desert.
Wow. That's amazing.
They built this city on a river which was glacial runoff. It was a powerful river at the end of the Ice Age for a long time, and then it just trickled and petered out because the ice all melted. And the city is like, uh-oh, and all the people either died or moved.
Yeah. Wow.
So yeah, the climate changes. Question people have is, can we predict it?
Yeah, because the prediction is that it's always just getting worse. It's like politics.
Yes,
it's like,
yes, because people love the negative story.
And so it's always just getting worse and worse. And so we have to, quote, do something about it. Rob, do something about it.
Yeah, I don't care.
Okay.
Honestly, from a biblical perspective, preach the gospel. If I was an evolutionist, I'd be like, oh, the polar bears are going to die. So what? Something evolved to take their place.
True.
There's no purpose in an evolutionary world. And the only purpose in a Christian world is to preach the gospel. So either way, it doesn't matter.
The only purpose you're left with is something in between, where what you just want is you just want to have what we currently have and you don't want a lot of change. You're resistant to change.
People like to be able to predict the future.
Yeah, we're not even interested in animal hybrids. Like there's loads of interesting examples of this, but they don't get the kind of press that maybe new Siberian tiger cubs would get, or the death of a Siberian tiger would get, rather than the story of here's an interesting hybrid between a tiger and a lion. Like it gets stored into the press. It's just not as big of a splash.
Yeah.
But the story seemingly should be a bigger story because we're talking about a hybrid between lions and tigers. Oh my. So
but
that
the story
would be,
of, the Siberian tiger is going extinct. Oh
right.
No, give money to the WWF so we can save the tiger. Yeah, because negativity sells. Fear sells.
Yeah, change resistors.
But not only does fear sell, people who want to make money, they need to know. Are you going to invest $1 billion building a skyscraper in lower Miami?
No.
I mean, is that wise? Or should you build it in Atlanta?
Yeah.
That's a big decision.
Well, not in Atlanta, not with this heat wave.
Yeah, well.
Not in hot Atlanta.
Skyscrapers have air conditioning, so we're okay.
Well, I like the idea of going underground, personally.
Yeah, except in Atlanta, you'd have to burrow through granite. It's not limestone. It's hard
You forgot
rock.
to mention that in our terraforming episode.
True.
You got my hopes up.
Well, like Elon Musk's boring company, they really are pursuing digging giant tunnels. And the one that they're pursuing first goes down the middle of Texas underneath the Blacklands because it's nice, soft material.
Yeah.
And I think it's like Austin to Fort Worth or something like that. I think that's the plan. I could be wrong. And they could maybe never build it. Maybe it's just a pipe dream. But that's the target site. Because the rock is so soft down there, they can bore a lot of rock really quickly.
Wow. Okay. Makes sense.
Yeah. Manhattan, it was hard building those tunnels in Manhattan. I mean, not only is Manhattan Island caught between two active fault lines, and not only is the world's largest copper deposit, but the rocks are really hard.
Wow. Then, okay, so climate change.
Okay. I grew up on Long Island, as we've said several times in this episode already. Land that I love. Anyway, I grew up on the end of Long Island, not the New York City end, but I actually lived on a dirt road at a marina. So I was a country boy growing up. And I lived on the glacial dirt that was scraped off of New England and dumped out in the ocean.
Wow.
In fact, if you look at Long Island, there's 2 forks on the east end. That's 2 series of hills. Each series of hills was the front edge of a glacier. So the glacier came down from New York, pushed out into the ocean across Connecticut, out into the ocean about 15 miles, backed up, then came again, but didn't quite get as far as the first time. So it didn't erase that set of hills and deposit another set of hills and then backed up again.
Wow.
And I've been across I've been to the middle of the country and seen some kettle holes and all sorts of glacial scraping examples in like the Wisconsin area. And I've been all the way to Washington State, and I saw the edges of the glaciers in Washington State. There is a line of glacier material going across the entire country. So clearly, the northern part of the United States was glaciated. Therefore, the climate does change.
So one of the things then that you're highlighting indirectly is that a lot of the climate changing that we would notice that would bother civilization is the civilizations that are too close to the oceans and to the ice.
Yeah, but also you have to grow food. And if the weather changes, what do you do then? Because we can grow lots of things in greenhouses, but not wheat.
Not that scale.
Yeah, not corn. So maybe climate change would be great for the Manitoba wheat farmers. Maybe they would love it if it was a degree warmer every year. Woo-hoo-hoo. Or maybe it would be a disaster because maybe it would change the wind patterns and bring drought. It's hard to tell.
So with climate change, hypothetically speaking, maybe it's not, I don't want to be a pessimist and I don't want to be an optimist and just assume that it all works out in our favor and that we get 72-degree weather across the board and, the deserts get covered over with green grass and less trees. But somewhere in between being a realist, maybe the more realistic problem that we would have to face is just relocation. Yep. Because the weather is going to change doesn't mean it goes away somewhere. Like the inhabitable zone is just moved, and nobody wants to buy and sell property around the weather changing.
That's right. And I think I'm going to strike a tone with the audience here. My problem with climate change is not the science. It's the red streak that runs through it.
Yeah. Okay.
It's the politicians and issue pushers trying to change our culture in what I consider the negative way, using climate change as a crutch. But the question should be an academic question. It should be a scientific question. It should be a question of calculations and numbers. And when we run all those calculations and all those numbers, it sure does look like the environment is heating up and will continue to heat up because of man's activity. So that's the other question. If the climate changes, is it natural or anthropogenic?
Anthropogenic.
Caused by man. Genic being Genesis, anthro being the root word for humankind, anthropology.
Yeah.
So can it possibly be anthropogenic?
Well, it's like we said I think we said this in a previous episode about Mount St. Helens, that a lot of what the volcano spewed changed the environment way faster than all the cities man's made for the last X number of hundreds of centuries or something. It was, or am I way off that base?
You're way off that base.
Okay, so by how much?
I'm not even sure what the numbers are anymore.
Okay.
I used to know those numbers. So potentially one single natural disaster can do a lot of climate change really quickly, but that's a punctuated event.
Okay.
Maybe like a giant, like Krakatoa or Santorini or Mount St. Helens or some other big volcano dumps a lot of carbon dioxide into the atmosphere once.
Okay.
Over a year or two, that gets absorbed, gets precipitated, and goes away again. So if we stopped all industrial output of CO2 today, it would take, I don't know, maybe a decade or so, maybe 5 years for all that to be all absorbed and precipitated out. But we can't do that.
Yeah, we're not going to do that.
No, we're not going to do that. Third world is certainly not going to do that. They're changing in leaps and bounds. But interestingly, the United States has reduced our carbon footprint more than I think any other industrialized nation. Or if not, we've something, again, the numbers escape me, but it's like we met the Paris Accords and then some because of fracking, because of natural gas. Natural gas burns cleaner and you get more heat per unit than you do with coal. And so it's a more efficient carbon source. In other words, you get more energy per atom of carbon with natural gas and you get energy per atom of carbon in coal or oil or gasoline. And that's really interesting. So this horrible thing, all the environmentalists are like, fracking is terrible, blah, 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 you're dumping all this carbon. Wait a minute, we're actually reducing the amount of carbon we're using because of the efficiency of the natural gas burning plants.
How long have we known that?
A couple of years at least.
Okay, so not for terribly long.
5 years ago when I first started hearing about it. Yeah, because you're a big industry and you have a choice. Am I going to build a coal burning plant or natural gas burning plant? Well, there's no natural gas. Oh, fracking, what's that? Hey, we got lots of natural gas. Okay, we'll build a natural gas burning plant. And everything changes. The big power plant out by Cartersville. If you ever gone on the west side of Rome, there's always gigantic lines of coal cars lined up, ready to go. And it's amazing how much coal we can burn. But because of environmental laws, and by the way, I'm a big proponent of environmental laws. I at first hated them, but as we get more money and as we get more infrastructure, it just makes sense to not dump a bunch of sulfur into the atmosphere or lead from leaded gasoline. Or, I don't like corn alcohol in our gasoline because it destroys my lawnmower. It's 2-stroke engines have a big problem with that. But you just add a little bit of, fuel treatment to your tank and you're fine. You're good to go. And I don't let my gasoline sit around for a year. I dump it in my car and burn it there. But besides that, and I don't like the idea of growing corn to burn in car gas tanks. It just seems dumb. Except, so what? It's renewable. You take the carbon out of the air, put it in corn, put that into your gas tank, you put the carbon back up into the air, it goes back into the corn again. That makes sense at some level. But taking sulfur out of coal was a big deal, an important deal too. But that means that we can't use Western or Eastern coals. Pennsylvania coals, West Virginia coals, they have a high sulfur content. So the coal miners out west are like, woohoo, yeah, you're going to use our coal because it has a lower sulfur content. So they made a mint and the coal industry in the East got destroyed. But see, that's another question. Climate change would do something similar. It would shift money to different places. And it's hard to predict. Therefore, people don't like it. Therefore, we're all freaked out. And then the communists are using that as a wedge to start trying to control our behaviors.
Fascinating. And complicated.
But going back to our discussion on terraforming, it's the same question. That's climate change. If we reduce the amount of carbon in the Venusian atmosphere, it will reduce the surface temperature of Venus. Why is that a debate? That's just like science. It's like basic, easy to understand. But if that's true, the same is true on Earth. And yeah, carbon dioxide is not a great greenhouse gas. Water is better. Methane is better. But water and methane aren't increasing. We've doubled the amount of carbon dioxide in the atmosphere over the last 100-something years.
Wow.
I remember listening to Rush Limbaugh in his early years, and I'm sure he kept on doing it. I just have to shake my head. It's like, dude, get off the science and just talk about politics. Because he always had this shtick where, hey, we can't even predict the weather next week. Ha ha ha. How can we predict it in 100 years? Ha. That's like, you moron. We talked about this earlier, I'm sure.
We touched on the idea of predicting the weather. Yeah. But not Rush Limbaugh.
That you can predict the weather tomorrow. You can predict the weather 6 months from now. It's going to be winter 6 months from now. It's going to be cooler than today. I can guarantee you it's not going to be 98 degrees 6 months from now here in Atlanta. Well, using those climate forcing things, sunlight and things like that, we can say, oh, but if we change this, we will change it downstream in the future. And we now have supercomputers. We have the ability to model things we couldn't even dream of 10 years ago. And all the climate models are pointing toward warming. Some more than others, some less than others. Okay, fine. But we have an instrument problem.
Really?
Yeah. You know how we keep having the warmest year on record and setting all these record temperatures?
Yeah.
Well, over the last 10 years or so, they changed the way they measure things.
Oh, but they didn't bother to revise the way it would affect the statistic over time.
In the past, we used mercury thermometers. Now we're using digital thermometers, which have a faster response time.
Oh, that makes so much sense.
And if you're not depending upon a guy at a weather station walking out to the field station once an hour and taking a reading and writing it down, you have an instantaneous response from a digital thing that's sending a signal to a central station. Therefore, the number of record high temperatures might be a fluke of the instrumentation. Have you ever seen one of those boxes? It's like a white box with slatted walls. It's on a stand. It's maybe 8 feet high or 6 feet high, standing out in a field somewhere or stuck on a building somewhere.
Yeah.
Those are weather stations all over the country, all over the world. And up until recently, they're all the same. It was a standard shield for the weather instrumentation on the inside. Well, now they're using very small little plastic caps out in the sunlight.
Oh, that changes everything.
It changes everything. And ground truthing that is very difficult.
So, okay, so are you saying it's sort of like a mild case of what happens to my car sitting in the parking lot all day? You know, if I go to my car in the morning, it's a cool 68 degrees, but then when I go back to it after the workday and open up the door, speaking of hot Atlanta, it's 103 degrees in my car just standing there and baking in the sun.
Now imagine that you've been measuring that temperature in the morning and the evening when you got to work and when you left work for 100 years. And then you get a promotion and now you're parking in the shade.
The global cooling.
Exactly. That's what we're talking about. And plus you have the urban heat island effect. Cities are hotter than the country because buildings block the wind, the asphalt absorbs heat, et cetera, et cetera. So there's issues there. And yet when you look at the older stations, like they don't change very much. And we have another problem. Back in the day, looking at a mercury thermometer with a guy's eyeball, there's user bias.
That's true.
Some people would record 30.5 degrees more often than 30. Some people would record 30 more than often than 30.5. And you look at the records and you're like, wait a minute, you know, Joe was obviously measuring the temperature at this station. And then Fred came on, Joe retired, and
yeah,
you can almost see that. And so, we're basing the whole climate change debate on data collected in the 1600s. Are you kidding me? 1700s, no. 1800s, early 1900s.
Yeah, not really accurate.
No, it's not really accurate. And that's a massive part of the problem is predicting things based on data that's imperfect. And yet all the climate models indicate that the Earth will be warming.
So are there conditions that would be a reset to cool things off?
Yeah. And what people are proposing is a radical reduction in the amount of carbon dioxide that we're producing as a society.
So I'm not necessarily talking about the man-made attempts to reduce the carbon, but just are there natural circumstances that would reverse the issue?
Oh, sure. We could actually just spread fertilizer in the central oceans, and the phytoplankton bloom would be so extreme that it would just suck up all the carbon dioxide from the atmosphere, and then the phytoplankton would die and sink to the bottom into the mud. And
so is this sort of like our terraforming suggestions that, you know, pie in the sky if money was no object? Okay.
Yeah, and that's possible.
Because it would be much easier to do the impossible on planet Earth than on Mars.
Oh, absolutely right. Yes.
Can we just like re-terraform planet Earth? It might not be a bad idea.
Well, we could plant forests, and the trees suck up carbon dioxide. It's called wood, and all that biomass would reduce the amount of carbon dioxide in the air. There's things like that we can do, but you know, we've invented solar power, and solar power has gotten 100% more efficient over the last decade or so. I mean, it's incredibly better than it used to be, and we're constantly incrementally improving our solar technology. We've also had wind farms now that we did not have before, and everyone's like, "Oh, wind farms are such a joke. No one ever makes money. These things burn out over time." Well, no, they are making money with wind farms, and we know wind is variable, and we knew that when we built them.
Yeah, of course.
Given the average wind speed in this area, or the average number of days above a certain minimum amount, okay, you know what? Well, let's put the wind farm over here in Nebraska, but not over here at Texarkana. That's not the right spot. And so we know where the proper wind areas are and where we should build wind farms. Now, is there a trade-off? Yeah. The amount of junk and refuse produced by these is a problem. And killing big birds is a problem.
Right.
And so, yeah, there are trade-offs, but it also makes sense to build them. Now, having them periodic is a problem.
Periodic?
Yeah, they only produce electricity when it's windy.
Oh, that's true.
And solar's a problem too because they only produce electricity when it's sunny.
Yeah.
So we can never get rid of backup power. But like that was one of the big problems in the Chernobyl disaster. They were doing this test, and the city of Kiev said, "Oh, hey, can you not do that test at 7:00 in the evening? Can you just wait a little while until after? You know, we don't want the power to go off in Kiev." And so cities and municipalities, government regulators, and power stations, they all talk to each other. Oh, we got to take this generator down for maintenance. Oh, okay, we'll turn on one in Peoria. And so they're always regulating which plants are producing at which times. And power plants like to have a constant volume. So where I used to live in Rome, in Georgia, they did something ridiculous. They had a lake, and they had a dam on the lake, and the dam had a power generating station at the bottom of it, so they could drain the lake and run through the turbines and make electricity. And what they would do is they would pump water uphill into the lake.
That
and
just reuses the energy,
and
right?
generating it through the lake to make electricity.
I'm not an electrician and I know that.
Except it was brilliant.
Oh?
Because they could pump water uphill when electricity rates were at their cheapest and run it through the generators when electricity was at its highest. And economically, it made sense, even though it was actually wasting electricity.
Wow.
But they also had the ability to buffer other perturbations in the electrical chain. They could just say, hey, we're having too much electricity and the Cartersville plant isn't producing enough. Turn on the thing in Rome. Open the floodgates, boom, and balance it out. So that's the status of wind and solar. We have to balance it. It will be great to balance it with a nuclear plant, but nuclear plants are even harder to up and down regulate. Natural gas plants are easier. You can stop the thing. You can get it to go faster or slower depending on how much electricity it demands. Nuclear is a little more of a lag when you say, hey, turn up the power. Sure, let me drop the control rods and do this and do that, and it'll slowly increase the power.
So what would you predict would happen if the climate over civilization or farming country were to change rapidly or dramatically?
If we indeed had a rapid climate change, which I believe happened after the flood anyway, but if we have it happen in our modern times.
So something at that scale, okay.
There would be,
my mind wasn't going there.
We don't even have to go to the scale of the Ice Age.
Okay.
We just need a 6-inch change in sea level.
It's true.
And all the ports in the world shut down. I mean, trillions of dollars. If we had a 1-foot change, every single port in America has to be restructured.
And that's what a lot of people are concerned would happen.
Yeah. And all the cities that are based on the coast, Miami, DC,
goodbye.
Boston, New York, Portland, Seattle, Los Angeles, Houston, trillions of dollars of infrastructure changes. We will never build another hospital or school for 100 years if we have to do that.
Wow.
And that's a huge issue. And that's a logical question we should ask. If this happens, what would we have to do? And so it's a discounting question. If we can predict the future, what's the risk of choice 1 and what's the risk of choice 2? And do we really have to worry about it? Well, yeah, we do. Because there's nothing scripturally that promises that the environment is going to be absolutely stable. And we know sea level has changed in the past by a lot. Even in the modern time, sea level has changed. And if we get significant glacial melt from Greenland, you're going to get sea level rise. If you get significant glacial melt from the ice cap of Antarctica, you're going to get sea level rise. And we now have satellites that are measuring this extremely accurately. And they're put up there in order to do exactly that. And they're measuring the volume above sea level of the ice in these places, and it's going down. We can measure ice loss in Antarctica. And sure, it's only led to a 1 or 2 centimeter change in sea level so far. Okay, fine. That's almost not noticeable when talking about 3-foot tides.
Right.
But if that continues, we're going to have big issues, and it's going to be a very expensive issue. So
it's not so much rapid, but it's still dramatic.
Even if it's slow, even if it takes 100 years, we're still going to have to do the same things. If it's dramatic, then if it happens over a year or 10 years, that's a really, really, really big problem. I mean, South Florida could go underwater with a 1-foot change in sea level. That's millions of people would be displaced. Where are they going to come? They're going to move to Georgia. I hope you own a house before that happens, because your real estate is going to skyrocket. And if you're renting at that time, you'll never be able to afford rent again. Because all the rich people from Miami can come, I'll pay anything. I just want a house. Yeah.
That would happen all right. That's how it goes. Practically already has.
There is a particular glacier in Australia, the Doom Glacier, the glacier of absolute eradication of humanity. And it is predicted that if the ocean gets, it actually pushes out into the sea, but it's sitting on the bottom of the sea. There's so much weight of ice above it, it's actually squeezed out all the water. It's sitting on the bottom of the ocean.
That's incredible.
And it goes way out from the coast and then hits a ridge of land that's underwater, but it's like a bathtub of ice.
Yeah.
And the ocean has gotten over that ridge and started to penetrate underneath the glacier.
Oh, yeah.
If it floats that glacier, they're predicting a massive change in sea level across the world, 6 inches to a foot. And it could happen very quickly. So that's a real question. Will that happen? And what would the effects be? And what would it take to do it? It's not like the communists are trying to control our lives. No, it's a scientific question, and it's really staring us in the face. But Dr. Don Batten, who works for CMI, he wrote CMI's main climate change article called Anthropogenic Global Warming, a Biblical Scientific Approach to Climate Change. I remember when I heard this was coming out and I was terrified. And I told the boss, I said, I want to see this because I know creationists who have said some really ridiculous things about climate change. And he said, you'll see it. And so I finally did see it. And I can say that I did not write the article, but I had a large impact on the article and I revised heavily and we went back and forth for a couple of months. I mean, I cannot tell you how many hours I spent helping him and him instructing me on what he really meant by things. And his calculations for that glacier in Greenland is like 0.2 centimeters sea level rise if it melts.
So what if it just floats? Would that also kind of offset?
So floating and melting is the same thing.
Okay, because earlier you said floating. My mind went to picturing a glacier like actually bobbling in the water and thinking, okay, so that's worse than if it melted. But nope. Gotcha now.
As soon as it floats, it can melt entirely and it doesn't change sea level. But so, if it's on the ground, all that water is not underneath it.
So a few centimeters, but they're talking like it's going to change things way more.
Exactly. And I pushed back on his calculations and I pushed and pushed and pushed and pushed and pushed and I couldn't budge him and I don't think I was right. He said, no, this is the length of the glacier. This is the height of the glacier. And you also have to account for the fact that X% of the glacial melt won't matter because that's displacing water for water. So we've subtracted out a calculation to all these calculations. And I'm like, yeah, I think you're right. I think they're wrong about the Doom Glacier.
So in the scope of potential outcomes, as I was saying before, with sort of a realistic approach, what is the likelihood that a significant amount of glacial ice would melt and rise to the danger zone? Would it take way more than that glacier accumulatively to get us there? And are there other significant glaciers that appear to be,
The main glaciers are Greenland and Antarctica. There are other glaciated areas, but it's such a small component of the total that they don't really matter that much. But the Greenland ice sheet's over a mile thick, the Antarctic ice sheet's over a mile thick. If you start getting significant melting of these, you're going to raise sea levels across the world. And that is happening.
But realistically, are they going to melt enough to make that kind of dent?
That's the question. And we don't know the answer to that. But given all this computer modeling and the realistic assumption that increased carbon dioxide in the atmosphere will raise the average temperature of the atmosphere, that's kind of scientific, we would expect some melting. Oh, and we're seeing melting. Given the fact that we can measure carbon dioxide increase and it's not tanking because the world is industrializing rapidly and all the third world countries like, yeah, we want coal burning plants too. We want, secure electricity and things like that. And so carbon is continually being pumped into the atmosphere. And so now we have the question of what about tomorrow? And yet something crazy happened. We had a year 2 years ago with no sunspots. After sunspots were discovered, sunspots then disappeared for a long time. We call it the Maunder minimum. It's also about the time frame of this other thing we call the Little Ice Age. They correspond. Sunspots produce cosmic rays. They produce stuff blasting away from the sun. Well, that affects us here on Earth, and they think that cloud production is based on charged particles in the upper atmosphere. Therefore, there's a relationship between the sun's activity and clouds is directly proportional to how much sunlight gets to Earth. More clouds equals less sunlight and more cool Earth. And so, well, if we just went through literally 0 sunspots in a year, we just hit a minimum. And now we're starting up a new solar cycle. Well, will we have a couple minimums in a row? If so, we might have a cool period. And that might mask the effects of global warming. Everyone says, see that? The world didn't warm, you dumb scientists. Okay, so what happens when the sun gets into gear again? It might jump up to where it's supposed to be. Maybe it takes 100 years for the sun to get back in gear. Well, maybe the environment will jump up to where it would be 100 years from now if the sun didn't do that. We don't want that. We don't want a rapid change. Rapid changes are hard to deal with. We want nice and slow and gradual changes, and then the world can continue on and everyone's happy.
I'm starting to feel a little sweaty.
Yeah, me too. Because
we have the AC off in the room.
Can we have the air conditioning on? Just let the audience listen to it going rum, 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 rum. We'll survive another 15, 10 minutes. We're all right.
For our listeners' pleasure, we do turn off the AC.
Excuse me. It's time to stop.
Okay.
That was amazing.
Yeah, for our listeners' sake and listening pleasure, we did turn off the AC just for you guys.
Because our studio here at CMI, we have a little box AC inside the room. And just to keep it cool, because it's basically a box inside the warehouse, which is not cooled or heated.
Yeah, it's a box in a box.
Yes.
Yeah.
All right, so problems we have to wrap up our discussion on climate change. One is feedback, positive feedback. If you get the glaciers melting, will that change something that causes the glaciers to melt even faster? If you get carbon dioxide going to the atmosphere, would that melt the Siberian permafrost, which would dump a lot more carbon dioxide into the atmosphere? Those positive feedback things are very difficult to predict, but there are several of them that we're worried about. And the permafrost is a big one. There's a lot of carbon in the ground in Siberia. And if that warms up, bacteria will get into it, and a lot of carbon will be released into the atmosphere. Could have a significant effect. A lot of this, though, is based on a misunderstanding of Earth's history. Scientists have a very hard time explaining what caused the Ice Age, a notoriously difficult time describing what caused the Ice Age.
And it kind of begs the question, why did things warm back up again?
Yeah, it does. Because once you have a bunch of snow, the snow reflects the sunlight, and you had this feedback response, and it should keep on cooling. But we got to understand, the Ice Age doesn't mean the entire Earth is covered in ice. There's still tropical rainforests and coral reefs during the Ice Age. It just means that the temperate zone has shrunken, has come down in latitude, and the polar zones have increased. They've also come down in latitude. But I call it the secular world. I hate saying that, but the secular scientific model has a problem describing the Ice Age because they don't have a real forcing factor. We know the sun changes in intensity over time. Okay, and in fact, it changes more in intensity than any other thing. The only other thing they have, which is what they fall back on, is called the Milankovitch cycle. The Earth wobbles on its axis, and sometimes the Earth's orbit is more circular, and sometimes it's more elliptical. And there's three main wobbles, we can call them, in the Earth's orbital data. And they have a periodicity to them. And if it's true, harmonically, when those cycles line up, that should affect the amount of sunlight striking the Earth. And that should trigger an ice age or end an ice age. It's called, that's the main idea driving the Ice Age belief, or the main explanation they found for the Ice Age. There are multiple issues with this. The amount of change is minor, and so they have to go with a little teeny bit of change from an Ice Age to a non-Ice Age. So they need a feedback, a dynamic feedback, and they have a trouble explaining that. When you start adding that to physical models, you get runaway problems. It snaps between two extremes, and once you go to extreme, you can't get out of it. So the orbital forcing mechanism, it's not really satisfying. Physically, it really doesn't explain the problem. I think Noah's flood explains it beautifully, but the physical forcing from the orbital dynamics really doesn't do it. So because they need to have a little bit of change producing a radical effect on the environment, imagine what a little bit of change today might do to the environment. That's where the global warming fear comes from.
Okay, that makes a lot of sense.
That is the root cause of the fear of global warming.
And meanwhile, from a creationist point of view, with the flood in mind, you understand it took something much more cataclysmic.
Yeah, something huge. It produced a lot of heat that produced a lot of evaporation that came down in polar latitudes as solid precipitation.
That could cause something like the Ice Age, which didn't even cover the whole Earth.
No, it didn't. And it lasted a few centuries and melted back until today's values. So we have two very different ideas of what causes Ice Age. And so this is the global warming debate. And it's, if we had ice ages in the past, if the Earth's climate can change radically, then it can change radically. And what caused it? Oh, a little bit of change in the orbital dynamics of the Earth. Oh, what about a little bit of change in carbon dioxide? Oh, well, actually, we've doubled carbon dioxide. Oh, no. And yet, even though those fears are true, it doesn't mean they're wrong. It doesn't mean climate change is impossible. It doesn't mean that a lot of climate change is impossible. It doesn't mean that the Greenland and the Antarctic ice sheets might not melt. And if they melt, we know what's going to happen. So it's all a question of prudence and how much prediction can we do and what are we willing to do about it? And you know what? Do we just want to say, yeah, whatever, the world's going to burn anyway? Or do we want to say, I don't want to live in Miami. I want to move to Atlanta. Those are valid questions. And I wish everyone would just get off of their hobby horse. And I wish a politician would just be quiet. Because when you mix politics and science, you never get good science. And when you start throwing around millions of dollars of research money, yeah, you got issues with scientific accuracy and things like that.
Wow. Well, any other remaining comments you want to make? We got a couple of minutes to spare if you want.
From a Christian's perspective, our concern should be for the less well-off, poor, the destitute. We should be worried about spreading the gospel more than spreading climate change fear. But at the same time, poorest countries in the world will be the ones most affected by a potential climate change. Bangladesh is going to go underwater. The country of the Seychelles, they're going to lose most of their land. This is, big problems if it's true. So we need to deal with that. And plus, it's the industrialized world that's affecting these other places more than anything. The Seychelles, they're not producing any appreciable amounts of carbon dioxide. No, China and America and Europe is. And Africa's starting to kick in. So from a future standpoint, if 100 years from now, half the world is destroyed because it went underwater, those people are going to be really angry. And we who should know better, if we don't do things to help, well, then we will be deserving of blame. And so there's a big picture here. The world is a lot smaller than it used to be. We can influence world climate, and that is true. If we cut down every tree in the Brazilian rainforest, that will change the world climate. If we burned all the coal up in the ground in the same day, or within 100 years even, that will affect world climate. As we harvest lots and lots of fish from the oceans, well, that affects the amount of plankton in the ocean, which affects the amount of chlorophyll, which affects the reflectivity of seawater, which affects the primary productivity and the packing of carbon from the atmosphere into the ocean sediments and away from the atmosphere. All those things have an effect, and we have the ability as humans to change the world. And I know a lot of people don't want to hear it, but it is true. And we need to be responsible world citizens. Now I sound like a liberal because I just said world citizen. Well, no, it's true. We are world citizens. And Christians have always thought a bigger picture than most other people. In fact, Christians should have been driving the whole climate change debate, and we let the communists do it. And it kind of disappoints me a little bit. Anyway, that's my final thoughts.
Very good. Very good.
Hope so.
I think this is an episode worth listening to 2 or 3 times.
Maybe.
Chew on it.
We did say a lot of nuancy things. We kept away from the big numbers on purpose. I don't want to talk numbers.
Right.
Yeah.
Well, and you don't get this perspective from many other outlets.
No. No. The conservative outlets, you don't hear big appeals to big science.
Yeah, chew on this.
Yeah.
Thank you, everybody, for joining us on this episode. If you found this episode interesting in any way, consider sharing it with your friends and family. And this episode's links to anything that Rob wants to throw in there about climate change and things he referenced are available with this podcast and most podcast apps. But you can also find it on our website, which is nightowl.fm/equinox/64. And if you want to get Equinox Plus, that is where we have bonus episode content for our supporting members. You can hear more from us with that series. That's available through Patreon. You can get to that in the show notes with a link to the Patreon. You should also check out Biblical Genetics, which is Rob's other project. Biblical Genetics is also available on Facebook and YouTube, where you can catch his videos and join the discussions in the comments. And if you want to find me, I'm at JCS Darnell on Twitter, or take a listen to my other podcast, Hi-Fi, which is available at nightowl.fm/hi-fi. Until next time, goodbye, Rob.
Goodbye, Joe.
You've been listening to Equinox. So I know it's a little bit of a change of subject, but we should hop back into Beequinox.
Oh, yes, Beequinox.
Buzz, buzz. It's been a while. But we do have more bees, and they've had more time. They've been growing the colony. How are your bees doing?
Well, I finally did get my colony opened up and looked at it, and it was about the same as it was last time I looked at it.
So, but when would that have been? Maybe a couple of months ago?
Yeah, 3 months ago or so.
Okay.
I can tell that they've had several broods. Because the honeycomb they drew is darkened. Every generation gets a little bit darker. You've seen some pictures of beekeepers with like black honeycomb. So I know they've had several broods. They still have a large population. I know that they've got some honey in there, and they're actively producing new babies. They haven't pushed into the second half, though. There's bees over there, but they're not putting anything down. So I thought about taking out the queen excluder, which doesn't need to be there. And the first comb past the queen excluder has brood on it. So I know the queen is getting there. So I cut her off from the backside. And while I was pulling things out and looking at them and putting back in, I said, I don't know if this is smart or not, but I took a comb with brood and honey and put it on the other side of the queen excluder. All right, but I didn't block it off or anything. But I'm thinking I should have split this hive.
So hypothetically, does that mean that there could be a queen raised on the other side?
Hypothetically, yeah. And if I had found a queen cell, I could have put it over there and then blocked it off, and I would have had to.
Purposefully, yeah.
Yeah, purposefully. But I think it's a little late in the season to do splits.
Oh, okay.
And I just want to get this one through this year and into next year, and I'll be happy if I have successfully overwinter it and they're doing well. And then I'll split it because we're starting off with different things than we had last year, which was nothing.
So during the month of August or so, we have more pollen from the kudzu.
Yes. Have you smelled the kudzu?
Not yet.
I went biking on the Silver Comet with my daughter on Saturday morning, and she noticed the grape smell. It's like kudzu.
Nice.
So the kudzu is blooming.
So what do we call this? Do we call this a pollen harvest, a honey?
No, it's nectar. It's a nectar flow.
A nectar flow.
Yeah, they've been harvesting pollen all summer. I've kept on seeing it, different colors. But this is going to be a nectar flow season for the next month or so. And this is what they're depending upon to have their winter store.
Yeah. So in my case, the first 10 frames are very well developed. As you know, they really developed the first several rows pretty fast.
The opposite is true for mine. I have nothing on the first 3 frames.
Even now?
Yeah.
Okay, curious.
And then I have some honeycombs that are about half drawn. And then I have those 3 frames that are completely cross-linked.
Yes, in the cluster
heavy.
In the middle.
Yes, and they're heavy. So, man, there's a lot of honey
it's
in
like
there.
3.5 frames that are in a huge webby apartment complex of bees.
Yes, and so I'm going to give that to them. That's their winter store.
Yeah. There ain't no way we're going to be able to make any honey out of there.
Oh, you can, but I don't know it could be a lot of brood in there too, but I don't think so. I think it's honey.
I don't want to hurt them.
Because the brood's all in the back.
The queen's in there?
No, my queen's in the back.
The back?
Yeah, right? I mean, halfway in the middle of my hive, right next to the queen excluder.
Interesting.
That's where the brood is being laid, in the backmost
I took it for granted that the queen would want to be in the central hub.
I did too, until I realized that, there's brood here. Like literally the last thing before the queen excluder.
I might have seen my own queen and not realized it.
Oh, maybe. Anywhere there's brood, there's been a queen. Maybe not today, but she's been there within the last couple of weeks.
Makes sense. So yeah, frames like 1 through 8 really developed. And then 9's
By the way,
so much.
for the listeners, who, if you haven't heard us talking about our beehive setup, we're not using a standard white square box beehive like you've seen. That's called a Langstroth hive, where they typically have 10 frames in a smaller box. We're using a
horizontal bar hive.
A horizontal bar hive, but it's also deeper than a regular beehive. It's got a much larger frame, and there's about 20 frames in one box. So there's more volume in that box than a standard white beehive box that you've seen.
And we have the queen excluder in the middle, so potentially half of it could be honey only.
Yeah, we were kind of hoping that they would fill up that half of the box and then start packing away honey in the other half because the queen can't get there. But
this just hadn't been that, what do you call that, nectar flow or honey flow?
Nectar flow.
Okay, there hasn't been the nectar flow of late.
No, of late, but we knew that too.
Yeah.
Main nectar flows in Georgia are in the spring and in the late summer, early fall. And June, July, there's like nothing.
Yeah.
And we saw it. And
but they're thriving. There's plenty of the bees. They're really happy.
Yeah. Tons of bees, tons of drones too, which, okay, it's a waste of honey, but whatever.
Yeah.
They're doing well.
This seems to really bother you. I can picture you going out to your hive one day and just like picking out the drones and squishing them between your fingers.
I actually have killed a couple just because, but I thought about pulling a frame out and just kind of like vacuuming the drone comb. Because, I mean, they're important for the biology of bees, but not for the efficiency of honey.
Yeah.
I don't care if there's drones or not. I mean, so.
I wonder if that would throw their equilibrium off in some other way you can't predict.
I don't know, and that's why I didn't do it.
Yeah.
But there's got to be ways to minimize drone production. And
Interesting.
I'm not a good enough beekeeper to know that yet.
So yeah, frames 11 through 20, like your story, there's bees over there. They're checking things out, especially on the ends. They're not interested in the middle frames so much. They've started creating comb on frame 11, but it's not a lot and it's not complete. So
I just realized something.
Yeah. You should have seen the look on Rob's face. He got a light bulb moment.
Yeah, this light bulb went off. See, when I was doing this, I realized that, you know how we have an entrance on both ends of the hive?
Yeah.
And one entrance is blocked off.
Yeah.
And, well...
The side that has the honey only.
Yeah, the side that should have honey only, but I don't have any... I have bees in there, but no, they're not doing much of comb development.
Right. You want to put all the drones over there?
No, the drones I don't think can fit through the queen excluder.
Oh, okay.
I don't think. But I was looking at all my stuff and I realized that there was bees flying in and out the other entrance. And I'm like, I thought I had that blocked off. And I was looking around and I knew that I had this board that I could screw on the outside there that would block that off entirely. And I see the screw holes and it's kind of like lighter because it was covered over and darker where the weather had where the wood was exposed to the weather. And I'm looking on the ground like, what happened to this board? And I just realized I had it plugged up with paper towels.
Yeah.
And the paper towels are gone.
My paper towels are still there, but they've actually squished it to like form a path in the paper towel out of their way.
Oh, that's funny.
And not many of them are using it.
But where
Some
did
of them know
paper
it's
towel
there.
go? Did a mouse push it in?
Well, yeah.
I don't think so. There's no mouse damage on the inside. I didn't see anything like that. Did the bees fly away? I didn't see it on the ground. Maybe it's inside the hive and I didn't notice because I didn't look down the bottom all the time. But now I realize why I have two entrances in my beehive. And I walked away shaking my head like, how on earth did I not know that the other side was opened up all this summer?
Well, you didn't unplug it, so it didn't occur to you that it would be unplugged.
Yeah, but I forgot how I had plugged it. So, maybe I need to close it or maybe I should open it up and leave it open.
See, that's the thing is mine's been plugged all this time. And if there's only a few that realize they can get in and out of that back entrance.
Well, now that I put an active comb on the other side with nurse bees and whatnot, I think there might be more flying out that side.
Oh, good point.
I don't know how smart this is. Beekeeping is so experimental for me. I should really be doing it the normal way that everyone else does it, but I don't want to do it the normal way everyone else does it.
No, it's not your style. You never have.
No.
Any of the times you did
cut
bees.
my own path here, which means I've never been successful in bees.
yeah. Right. Well, how's your data going? You've been keeping statistics on the hive.
It's been very stable all summer, but I just realized something. When I took off my beetle traps a couple of weeks ago, and I noticed that the grid, the little holes that I had drilled in the mason jar caps were plugged with propolis.
Well, I was going to get to that too. That's happened in my case as well.
And so I cleaned it out, but I just realized that means that the one I installed on the side of the hive near the top where I have my temperature and humidity logger behind it is almost certainly propolised over.
Ooh.
Oh, so have I not been actually measuring the internal
data?
temperature? Maybe that's why it's been so stable because it's sealed. So now that I realize that I have to go back, take off the
Clean it off.
Yeah, well I have to remove the styrofoam and then remove the other thing of styrofoam and then look and clean that thing off if I have to. I'm not exactly sure what I'm going to see, and I'm like, I might have just ruined like half a summer's worth of data recording.
Ouch. So how do you clean off the propolis on the mason jar lids?
You take your finger and you go flick.
Are you really?
Yeah,
I
right
just
off.
imagine
Comes
it
right
would be
off.
sticky. Okay.
I thought it was going to be like, no, this is going to be terrible. You just run your fingers over, it falls right off.
Okay, cool.
Yeah.
Maybe it gets tougher to remove with age. Does propolis get tougher and tougher? I was curious. I don't know.
Don't know, but it sticks down through those little holes, so you get a little bit of leverage.
Okay.
And it's just click, 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 and comes right off.
Well, good. Okay, I'll have to do that.
My bees also on the outside of my hive. You know how I clad my hive in that styrofoam, that white styrofoam insulation?
Insulation.
Well, right near the exit, they're actually eating the styrofoam above it. It's like, guys, leave my styrofoam alone. Yeah. So there's a little,
it does nothing for you.
Dimple. It's like 4 inches long and 3 inches wide and maybe half an inch deep where they have scooped out the styrofoam. What's going on?
Kids, stop eating the fake fruit on the table.
What? I have no idea where they're doing that.
Those grapes are wax. Wow.
So here's the kudzu honey. Maybe we're getting some right now.
And for anyone who's curious, how would you describe that? It tastes grapey, smells grapey, but it also seems like it's got a floral quality to it.
I have heard different things.
Different opinions on the flavor?
Some people say there's no such thing as kudzu honey. There's no such thing as purple honey. And other people are like, absolutely right, man, it's purple. But one of the issues with beekeeping is they're collecting from a lot of sources and they're mixing over time different sources. So maybe some people see it and some people don't. Maybe you need to be in the middle of a giant kudzu field.
Now, like you were saying, they're available over at the Silver Comet Trail, which is publicly available. You ride your bicycle over there a lot, and I sometimes go out there to take walks with the family. And you can see the kudzu, you can see the flowers this time of year, and it smells grapey, looks grapey. Like
right where I saw you last time, where I saw you on the trail.
Yep.
That's where you got kudzu, and it smells purple.
And not far from there, up the road, there is a beekeeper, and he sells honey. And we've bought his honey before.
Really?
Earlier this year. And it tastes amazing, but you would never use it in any sort of recipes to cook like, baked goods because it's really strong.
Yeah, you don't want to waste that lovely flavor.
And it doesn't seem right. So maybe you want to use some very neutral flavor honey for baking some muffins. You can't do that with this kind of honey.
People like bad honey.
So you say
like
go with
honey,
it?
They like honey that clover honey has a little flavor. They like sugary honey with a little flavor.
Yeah.
And the issue with a lot of honeys is they taste different from one type to another, and you don't want to bake with that.
And I would say it's even like concentrated.
You
want to dilute it just to mellow out the flavor.
Yeah, and some of it is strong enough to be unpleasant. You should make mead out of that type of honey.
So if you just take a spoonful of this honey, it's kind of delicious and weird in its own complex way, and you taste 50 different things in one spoonful.
I love that.
That is really good and really cool. It can actually, is it true that it can help your immune system or reaction to local allergies or anything like that?
I've heard such.
Yeah.
But by the time they make honey out of it, that pollen is not in the air
so
anymore.
So it's old. Okay.
You can take bee pollen. And I did once, and my nose and throat swelled up. I couldn't breathe.
Okay, good to know.
Get throw the stuff away.
So I have no idea what happened there. I don't really have allergies, but I was like, that's a bad experiment. Throw that bottle away. It almost killed me.
Okay, cool.
Thank you all for listening to...
Well, we already said goodbye.
What do we say call it? Bee what?
Beequinox.
Beequinox. I'm thinking Beepocalypse. No, Beequinox.
That's a very different show.